Good afternoon, everyone. This is Chris Riley with System Source. Thanks so much for joining us at lunch today. Hopefully your pizza's in front of you or will be here soon. I'm joined today by Dave Ferg, one of our senior consultants. Many of you have had the opportunity to work with Dave on some of your projects over the years. So you know you bring us a good educational time today. So today we're taking a look at securing Azure storage as so many of us are moving more and more of our resources. So our infrastructure and servers and storage up to Azure, security becomes very, very important. And one of the things we've also seen, for those who may be newer to Azure, is that a lot of times the first priority is the migration, not the security of the pieces once it kind of gets there. So security is often kind of a second step, not necessarily built into the first migration. So this may be timely if you're newer there to go and make sure that all the pieces are locked down in your storage. So this is kind of a part of a continuing series of Azure topics that we've done around security. But today we'll kind of dive deep into the storage side of things. So for the agenda today, a few introductory remarks, and then Dave will jump into looking at encryption, key management, access security, taking a look at data backup requirements, as well as looking at monitoring using some of Microsoft's Defender tools. And then Q&A will be at the end, and I'll say just a little bit more about that here shortly. So a little bit of some housekeeping notes here. So first is we hope you have your pizza in front of you, but if you don't, just take a note of Julie Dellinger's email address, which will be coming up on the screen here in just a second. And so if your pizza doesn't show up here shortly, just go ahead and reach out to Julie and she can take a look into that for you. All right, during the webinar, so audio is in presentation mode, so you can hear us, but we can't hear you. But not because we don't want to be able to hear you, but what we want to make sure is that any background noise, et cetera, where participants may be, does not come through to the whole group. However, you can reach me at any point through the control tab, right there, control panel in GoToWebinar. Just reach out to me through chat. And any questions that you have at any point, just drop them into the questions tab, and then Dave will be responding to those questions at the end. I'll go ahead and read out those questions to him. Putting them in writing also has a benefit if it's something that's more in depth, maybe it requires a little bit of research. We can always reach back out to you after the session. The presentation is being recorded, as well as will be the presentation itself will also be made available to you as a PDF, so you can get that as well as the recording. And finally, there'll be an evaluation at the end, and we do try to make it a little bit fun for you to let us know how we did, but also what other types of resource you may need. Try to make it fun by doing a drawing from the completed evaluations for an Amazon $50 gift card. So the gift that seems to always fit. All right, just a little bit about System Source for those who are new, so briefly through this. So we've been around since 1981. There's about 70 of us here, and we work with IT professionals in a variety of areas. So one is when folks need to acquire new technologies. That could be Azure, for example, but most of our work is done in the data center, probably 80% plus of the work that we do. The other remaining part is going to be in-user computing, so all the laptops, desktops, printers, those types of things. But the bulk of our work is happening in that data center, whether that's going to be the traditional on-prem or cloud variants like Azure or Amazon Web Services, those types of things. But most of our work in the cloud is happening today in Azure. So regardless of whether it's on-prem or in the cloud, you're still going to need resources like servers and infrastructure and security, and storage, all of those types of pieces. So regardless of whether those are traditional on-prem varieties of that or the analogous ones for the cloud, we work in designing, kind of meeting the requirements, doing design, implementation, and long-term support of all of those technologies. So Dave and his colleagues in our consulting services group does that. So it's all part of Improve. So we've talked a little bit about consult and cloud services. Also a training arm, which trains in about 600 plus courses at any one point, right on our schedule. And that's going to be in all the Microsoft stack, like we're starting to talk about today with Azure, but also in about 2 or 3 dozen other both specific technology areas as well as vendor areas like Cisco certification, those types of things, all available through our Learning Center. Present is professional AV, so all the WebEx rooms, Zoom rooms, Teams rooms that we're in. So for huddle spaces, conference spaces, presentation auditoriums, so all the large monitors and projectors, microphones, speaker systems, all is a part of what our presentation systems group, in addition to digital signage. And finally, at the bottom, we maintain all these things, whether it's on a reactive basis, service and support. You call us when things go bump and you need some assistance. That could be whether it's during business hours or after hours. Just follow the voice prompts on our voicemail system when for after hours. Call the main number, or managed clients under managed services, where we are the IT department for dozens of organizations around the region. All right, some upcoming webinars that we have. So there's a couple listed here, and then we'll have additional ones coming up in July. So the next ones are going to be looking at Wi-Fi. So what have we learned after putting in 500 plus Wi-Fi networks? So we'll be diving into that next Tuesday, or Tuesday the 17th. And then on the 25th, we'll be looking at the Verizon report that looks at it's an annual report, so many of you have been in these sessions before with us, where it looks at security lessons, all breaches, and then does analysis. So we'll be looking at those. What can we learn from Verizon's experience across over 22,000 security incidents? With that, let me hand off to Dave, please.
Thanks, Chris. All right, and thank you all again for joining us this afternoon to talk about some security up in Azure. This is kind of another in a series of security webinars that we're doing with Azure, from identity security to networking security. Today's presentation is on storage security. And if you've attended any of these other webinars, some of this stuff will appear familiar because it's the same things just applied to storage now, but I'm trying to tie in all the different things that actually affect the your security and your storage. It's a big topic, so we're going to move a little quick and a little on the higher level. I just want to make sure you understand where these pieces fit together and give you an entire security picture. So let's talk about, again, another little agenda slide, if you will, in a little more detail. I want to talk a little bit about data redundancy up in Azure. Now, we're all kind of familiar with this. I'll move through this one relatively quick. We are going to spend a decent amount of time on storage encryption from the server side, or at the infrastructure level, at the host level, at the OS level, all the different places in which you can enhance the encryption that you already have or change the way it's being done. In that discussion, we will talk about the difference between platform managed keys. In other words, Microsoft will be managing your keys, or whether you want to manage your keys for encryption in the customer managed key realm. We're going to talk about access security, everything from access keys and shared access signatures to what role-based access control can do. And they all have a role to play. They all have places where they make sense for us. So we'll talk about all three of them there. We're also going to talk about access control through how and from where you can make your accesses. Can you make it from a public address? Is it only going to be from a private address? What kind of restrictions are we putting on source locations and those types of things? And of course, you need to protect your data from loss. So we're going to talk about the recycle bin style features here with soft delete and snapshots and backups that you can do. And of course, all of that's great, but if you're not monitoring, you don't know if you have a hole in your system or if you're being attacked. So we're going to talk a little bit about where Microsoft Defender fits into your security picture. And so that's where we're going today. And again, it's going to be a little quick because it's just a ton of information. So I want to just kind of get you thinking along these lines right now and knowing where pieces fit, so that maybe we later can have a conversation of what we want to do in your environment. So let's talk about redundancy. And again, I'm going to move this one pretty quick because you're probably all familiar with it. But when you open up a storage account up in Azure, you're going to get 3 copies of your data. And they can be replicated in different ways. One of them is the locally redundant storage, which is your 3 copies are kept in one data center. So you're protecting yourself against rack failure within a Microsoft data center. There's also a storage redundant configuration you can do with your data. In a region, there will be multiple data centers, and these 3 copies of yours will then be placed, 1 in each data center. So now you've upped it from rack failure to data center failure, and you would still have access to your data. And of course, now we can go geo-redundant. So if you want to protect against an entire regional failure, you can do a geo-redundant storage and put 3 more copies someplace else in another region, maybe from US East to US West or something like that, something outside the power grid area where you have a protection against power grid failure. And of course, we can there's a combination of the geo zone redundant storage, so you can be zone redundant in your primary region and then geo replicate that to another region. These are all selectable in your configuration of the disk. So when you go to make a new storage account here, you're going to just configure your redundancy to be one of these. And it's just a matter of cost as to which one you want to pick. When you click this, that's how your storage is going to be deployed. So consider what kind of what kind of redundancy you need to keep yourself protected against loss of access to your data by data center failure or rack failure. Just keep that in mind as you're making your plans. All right. So let's just talk about other kind of security. And so we're going to do a quick little overview slide here real quick of the types of things that we're going to be talking about. Starting with access control. Now this is just looking at this screenshot is of a storage account, looking at the overview and all the things that you can configure in here. One of them is the access control. So and we'll dive into that a little bit more. The redundancy that I just mentioned and we kind of went through right there. Access control, again, as to whether you want anonymous access. How do you want to deal with soft deletes at the blob or the container? Do you want to do versioning? So when you get into the configurations of these are the checkboxes you can check off, whether you want to have versioning for tracking or recovery capabilities or access control capabilities. All of that stuff is configurable for you. Where are you allowing access from? This screenshot shows all networks, but maybe you want to limit to access only from a particular virtual network, so that you can't have access maybe from the public world or from any other virtual network in your Azure world. So we can lock it down. Let's consider that the scope of your network geography from which you can make a connection to this storage. So this is done in the firewall setting. So when you're configuring, you can define what kind of public access you want to this, whether you want it enabled for all networks, which is kind of what you're seeing down here, enabled for just certain virtual networks, or you want to disable public access. And if you disable public access, now we're moving into the area of the private endpoint, the service connection endpoints, and things like that, which we will be talking about today as well. So we can protect from where access can be made to our system. So that's just what the overall console can show you here. And let's start diving in a little bit more into some of these things. Now, if you were part of the network security webinar we did a little while ago, this slide will look familiar. This is talking about the private endpoint. Anytime you have a resource put up into Azure, you put the Azure there, it will have a public IP address associated with it, and the access by default will be coming through the public IP address. But maybe you don't want that. So maybe you want to protect this resource from being hit from the internet. So you can turn off that access from the public access. That we saw that on an earlier screen where you can disable public access. And if you disable public access so that the public IP can't be accessed, you're going to need some kind of access from the internal world. And that's where a private endpoint will come into play. A private endpoint is nothing more than a NIC that you're putting into some virtual network that can connect, that will then be connected to your service, to the Azure service in the background. And when you need to access it, well, virtual networks in your Azure can possibly get access to it. A VPN from your on-premise world that has access to this virtual network world can see this NIC and make access to it. I don't have the slide on it now because I didn't want to drive into it on a storage security webinar. But when you create a private endpoint for a service, the DNS name that the clients are using to make the connection doesn't get changed, but through CNAME records points over to a private address. So the connection strings will all remain the same. This is something you can enable while a device is already been deployed and people are gaining access to it, because you're not changing the connection string. You're just changing the IP address that will get found. Service endpoints, similar in concept to the private endpoint in that it's protecting you against public internet access. So it's not allowing public internet access. But what it is doing is it's retaining the public IP address, but keeping the traffic on the Microsoft backbone. So it's a public IP address access, but it doesn't go out on the internet and route itself back in. So when do you use each one? I'm just going to refer you back to that network security webinar. There's a table I put in that presentation that says, here's when you want to use a private endpoint. Here's when you want to use a service endpoint. You can tell you're using a service endpoint in the routing because when you go to make a connection to a public IP address, it's showing this as the next hop, the Microsoft Virtual Network Service Endpoint, which means it's going to stay on the Microsoft backbone. So that's some ideas about how to protect yourself from sources, from where you're going to make your access. Let's talk a little bit about backup. And this, again, may be old hat to some of you, but let's just kind of complete the picture of security, because backup is a part of that. If your data goes away, you need to be able to get it back. You need to be protected in that regard. Backups are stored in vaults. So I thought I had turned that off. There we go. Are stored in vaults, either a recovery service vault or a backup vault. And you're probably in your environment going to need both of these. These are where the data is going to be stored. Recovery services vaults are used for certain of services within the Microsoft world. Backup vaults are used for others. So if you have a virtual machine and Kubernetes stuff, you're going to probably need both of these. And the Azure backup manages that. And it's just all that is the target. Now, in that target, we can make that an immutable storage so that you have protections against ransomware and things, because your backups can't be touched now. And that is a property of the vault itself. So when you're creating the vault, one of your settings is, how do I want to handle immutability? And your choices would be to be either disabled, or you want to enable immutability, or you want to enable it and lock it. Now, the difference there is, if you enable it, you can disable it. If you lock it, it can't be disabled. So those are the types of things that you can configure with your backup vault. So now you have a second copy of your data. In addition to the redundancy, you now have a second offline copy of your data that can be immutable. And if something goes wrong with your data, you get some malware in it or ransomware or whatnot, you have something to go back to that hasn't been touched. The recovery services vaults are isolated. There's no direct access to them by users. They can only be accessed through the Azure Backup Management operations. So that data is considered that offline and not accessible from your VNets and things like that. Role-based access control. So now we're starting to get into access control things. So let's do a little bit about role-based access control. It is where you can assign permissions to users based off of their user principal name. So this user can be granted X rights in Y locations. And the rights that can be granted could be based off of job function roles. So it's some kind of administrative role, like a database administrator or something like that, or privileged roles like your global admin type roles and things like that. So you could grant a user a role, and then they would have access to that resource for whatever. It's very similar in concept to NTFS permissions, if you will, because it's based off of their security principle. You can always check what level access somebody has. So you can check the access of any security principle or your own to make sure it is set the way you need it to be set. And this permission can be scoped to different levels within your Azure world. It can be all the way up at the management group, at the subscription level, at the resource group, or down at the resource. So here's where we would place it if you wanted to do some specific security permissions. You would put it at the resource level on the storage device itself. And that security principle may, can be granted maybe just like read permission or whatever permission you want it to have on that storage account. So again, it's the security principle that you're going to grant permission. What action are you going to allow them? Owner, contributor, reader, whatever, and where. And that is the role assignment that you're giving them. So they can have read permission to one storage account, contributor permission to another storage account, etc. All based off of who they are. And there's a link there if you want to find more information about role-based access control. Now let's look at this in the idea of, okay, do we use an access key to make access? Do we use a signature, or do we use role-based access control? Which one would I want to use, and what's the point of each one? Storage accounts have an access key. The access key grants you access to the storage, and it's not going to use your service principal to make access. You have the key to allow yourself access. Here, it's like putting your room key in to your room. Whoever has the key has the access to the room. So when a user wants to make access, or an application or something wants to make access, they get the access key for the storage and use that access key on the data plane to make access to the storage. They now have access. Plain, simple, wide open. Now, if your storage is dedicated to a specific purpose, specific type of data, and you have an application that needs access to all the data, this may be the solution you want to go with on that. If you want to tighten it down a little more and still give this non-security principal access, you could use a shared access signature. All right, so again, you go, the client app or the user makes a request to the access key, and then if it's a signature, that key signs the signature. The signature has now more limited rights for the user, and then I use my more limited signature to gain access to the storage. All right, now we'll show you a little bit in a future slide what some of those options are. And of course, then there's role-based access control. So we could grant a user principal account or a service object or something, machine account, access to these, based off that security principle, some kind of permission to the storage. So they all have a bit of a role to play, and they can all end up accomplishing pretty much the same thing. Access keys, you see them in the console for the storage, and you have a couple access keys that can be rotated. As long as I have this access key, I can get access to your storage. If I go with a shared access signature, first of all, it's going to use that key to sign this signature. So it's still the key that's the authoritative source, if you will. But now I can limit this signature to only allowing access to a certain type of storage with only certain types of permissions in only a certain time window from a certain location. So this is a little more secure. The timing issue is an interesting one, because now I don't have to, if I wanted to block somebody who had an access key, I actually have to rotate the key and then not let them know what the new key is, and they're blocked out. With a signature, I can time bomb them so that they can only work for a certain amount of time, and then the signature is no good anymore. All right, and again, it's signed by a key, so it's still the key that is granting the access. It's doing the authority, and the signature is filtering that. That's probably the way you want to look at it. In the role-based access control, we delegate what roles we want to somebody. So maybe, we give them a blob storage permission of some sort, or a table permission of some sort, or a queue permission of some sort. Here, the user is logging in with their security principal, and they're gaining the access they need based off of who they are. And this is where you can set the permissions. More times than not, you're going to be dealing with role-based access control. You're going to use access keys and the signatures for unique situations, for maybe applications or something like that, where you don't want a security principal doing the access. So they all have a place to play, but role-based access control is probably where you want to default for your day-to-day stuff. So let's talk a little bit about encryption. So we talked about access from where you are, what VNet you're on, what public IP address you're accessing, etc. We talked about access control, about who you are and how I gain permission. Now we're going to spend some time talking about how your data is encrypted for security. And we've all read the line in the Microsoft literature or heard it or something, that data is encrypted in transit and at rest. And that's true. But what we're going to talk about these next few slides is how and where and what your options are in these encryptions. All right, so in the in-transit mode, you can client-side encrypt. So if your client encrypts the data, it's going to be encrypted from the client in transit to the storage and be encrypted on, and it remains encrypted on the storage. So but that's being driven by the client, but that's one way of dealing with it. If data is moving between Microsoft data centers, Microsoft uses a data link layer encryption. So if you're going, we did that, if you notice that geo-redundant storage, when that data moves between one region data center to another, or from one data center to another within a region, it will be encrypted with data link layer encryption. And all user connections, when you just by default use TLS. So my workstation is making connection to an Azure resource. That traffic across the internet is all going to be TLS encrypted. So that's what they mean by in transit. In transit means data outside of their data center is encrypted, either because it's being encrypted by Microsoft between data centers, or just the standard TLS encryption between client and the Azure data sites itself. Right. Now let's start talking about storage at rest. And this is where it starts getting interesting and could be a little confusing, but here's some of your options. By default, everything is done server-side encryption. A storage account at the account level has encryption enabled on it. And by default, we'll use Microsoft keys, platform managed key structures for that. So that's the default. What's being encrypted? Well, you have a disk encryption key that is actually the key that for the encryption itself. And then you have a key encryption key. Now, this is the one you have control over as far as where you're storing it. The key encryption key encrypts the disk encryption key for protection, and the key encryption key can be stored in a Microsoft key store. That's your platform managed key. Or you can put it in an Azure key vault in your own resources, and you are managing the keys, but you're managing the key encryption key that manages the disk encryption key. So that's where the customer managed key and the platform managed keys are segregated, if you will. They're just in different key vaults, one that you have access to, one you don't have access to directly for your management. When you're creating systems, you can define what kind of, how you want to handle your keys. Do I want to Microsoft manage? That would be the platform managed key. Or do I want to manage them myself, which means I need to build a key vault into my resources. So when you click customer managed keys, I want to select my key from a key vault, and here's the key vault, and here's the key I want to use. So you will create a key, and this is the one you're going to use, and you manage it. You're responsible for any rotations or refreshes or changes or anything like that. So the configurations will walk you through what you need to do. You just need to decide whether you want to be the manager of your keys or whether you're okay with Microsoft managing keys. Server-side encryption is also known as service-level encryption. The service, the Azure service itself, is encrypting, and it's encrypting out here at the storage account. All right, so the service is going to put a layer of encryption on that, and it's a software-based encryption. You also have, when creating this storage account, the option of enabling infrastructure-level encryption. Now, this is in addition to, so this is a second layer of encryption that you're putting in. You have a storage account encryption, and then the infrastructure that is hosting your storage has encryption capability. So now you have a two-layer encryption, and the infrastructure encryption is managed by Microsoft and Microsoft only. So that would be a platform managed key for that encryption. But now you have a double layer of encryption in there. So if you have a requirement for that, Microsoft supports that through infrastructure encryption as one way of getting double encryption on things. Again, it configured at the creation of the storage account, and you cannot change it after the fact. So when you're creating the storage account, you have to enable whether you want infrastructure encryption or not on that, okay? Managed disks. This is something that's probably the most common for all of us because we all have our VMs, we have managed disks. Managed disks are no more than an abstraction of a storage account on page blob, which is your VHD. So it's a storage account. A storage account by default has server-side encryption. So your disk is encrypted because it's on a storage account. So that server-side encryption is there for you to use, and by default, it's using a platform managed key. So it's using the Microsoft stuff. So yes, if I just put a VM up in Azure and I create a disk on this VM, I know my disk is encrypted. Now it's the managed disk that's encrypted because it's the managed disk that is on the storage account. As we'll see in a future slide, when you create a VM in a Hyper-V world, the VM itself has a temp disk, the Windows has a temp disk, and then there's a cache that's part of the host. They're out on the Hyper-V world there. Those things are not encrypted by default, only the data disks and the OS disks that you have. But this temp disk, this cache disk, which is residing on the host, is not encrypted. And we'll talk about that in a little bit later. But your actual data is encrypted here. Again, okay, I probably should have clicked this for what I said earlier here. Since it's a storage account, they are on encrypted storage. So, rest assured, if you did nothing, your data is still encrypted and secure. What if you want to manage your own keys, though? Well, if you want to manage your own keys for your disks, your VM disks, if you will, you need to create a disk encryption set. You want to think of a disk encryption set like a container, if you will, that defines the customer managed key. So the disk encryption set will have a disk encryption key, which has a key encryption key, which you manage up in your Azure Key Vault. Now you just need to associate, oh, I'm sorry, I forgot to get this slide popping up. This is just showing that fact that you're creating a container. I'm going to use this particular key vault. Here's the key vault. Here's the key I want for the encryption inside of this disk encryption set. What you now need to do is associate your managed disks with that disk encryption set, and they will be encrypted. These disks, the managed disks themselves, will be encrypted with your customer managed key because they're in the disk encryption set. They will be encrypted. All right. And the disk encryption set encrypts the managed disks only. And again, that comment is around Your VM has more than just its managed disks. It has its temp, it has its cache, but you're managing the C drive, D drive, E drive type stuff with your key, and it's done with a disk encryption set. That process, if you wanted to see a flow chart of how that works, is you're going to create a disk encryption set. You will associate your managed disks into that disk encryption set. When that data needs to be decrypted for reading and things like that, the disk encryption set will do the authentication to enter ID that says, yes, you have rights to read the Azure Key Vault, so you can get the key to decrypt the data and get a hold of your data that way. So that's all this flow chart is showing here. It's storage side encryption using disk encryption set using customer managed keys. It's still an authenticated connection to get to the key vault, but it's the disk encryption set that's being authenticated to do that. Azure Disk Encryption is a second method for encrypting your managed disk. And here, what we are doing is we are moving the encryption from a disk encryption set, which is like a separate Azure resource. We're moving it to the operating system itself. So it can use BitLocker or de-encrypt if it's Linux. So it's going to be an OS managed encryption, just like if your VMs or your standalone servers on-prem. And so like anything with BitLocker, you're using some CPU cycles to do encryption, but it's managed at the VM. If you want to use Azure Disk Encryption and let the operating system do the encryption for you, the keys are stored in an Azure Key Vault, but you have to enable the Azure Key Vault, that's a special checkbox, to support ADE. What that's doing when you do that is it's granting the permission for VMs to make a request to get keys for the BitLocker stuff. All right, and it's done that, and the VMs will then get an extension put on them to gain access to the key vault, to gain access to keys. The encryption now can encrypt the operating system and data disks. Those are your managed disks. It can also encrypt the temp disk, which is inside of the operating system. What's still not encrypted, and there'll be a diagram coming up later, is the cache disk that's on the host that Hyper-V is using for this virtual machine. But we can now get more than just the managed disk. We are now picking up this temp disk and getting it encrypted as well. And again, we have a diagram coming up that will probably make this a little easier to understand. The data is then encrypted at the virtual machine by the operating system before being sent to the storage account. So it has an encryption that's happening in transit within the Microsoft data center. So from your VM that's on a Hyper-V host to the storage account that are both inside of Microsoft's world, that traffic between them now is encrypted because it's being encrypted it's kind of like a client side. It's being encrypted at the source. So that encrypted data is being sent to the storage account. So if you want encryption inside the Microsoft data center, then you're looking at something like Azure Disk Encryption to get some of it. Okay. When you're creating a VM's storage, this is configured in the disk settings. What disks do I want to encrypt? And what key vault and key do I want for encrypting these disks? So you can pick, if you back up one here, you can pick, I just want to do the OS disk, or I want to do the OS and all data disks that are associated. So this is your C, D, E, F drive letters, if you will. And here's the key vault for which I'm going to use for encryption. Okay. So far, we've talked about server-side encryption, which is by default. It's a service-level encryption, uses the Microsoft Platform Managed Key. We've talked about infrastructure encryption that you can add to that. We've talked about, now, in both of those, the only thing that's being encrypted is the data on the storage account. Nothing over on the Hyper-V host or at the VM itself, just on the storage account. Then we talked about managed disks. Whether you use, by default, you're using platform managed keys, and so anything you create automatically is encrypted, or you could use customer managed keys in a disk encryption set and encrypt your disks. And again, with both of those, you're only encrypting what's on the storage accounts or the managed disks, which is part of the storage account. You are not encrypting anything at the Hyper-V host or within the operating system's temp disk or anything like that. Then there was the Azure disk encryption, or where you're using BitLocker. Because that's the OS, it not only gets the managed disks that are in storage, it gets the temp disk that is on the VM itself. And then, of course, the encryption happens in transit. We also have host level encryption. So kind of setting this up a little bit, with server-side encryption, standard server-side encryption, this is the diagram I was mentioning for you before, the temp and the cache disks are not encrypted. And the path between the compute and the storage is not encrypted. So if I am using normal storage server-side encryption over here, whether public key or private key, this is what's encrypted, not this, okay? If I turn on encryption at the host, data stored on the host is encrypted. So the data flow between the host and storage is encrypted. So these two disks, we're picking up the temp, which BitLocker would do for us, but we're also picking up the Hyper-V host cache. That's being encrypted, even though that's not going to be sent to the storage device, or even the temp's going to be sent to the storage device. It is encrypted here. So on the host itself, it's encrypted. All right, so the temp disk is encrypted using the platform managed key. The cache is encrypted using this key because it's your data here. So this is the key that's being used to encrypt this. And because it's being encrypted there, anything that does need to go, because encryption is starting here, anything that's going over to storage is now going to be encrypted in transit to the storage, again, inside of Microsoft World. So just to be clear, back when we talked in the earlier slide saying, you know, your data is encrypted in transit, that was in the context of an external client talking to the Azure platform, going across the internet, that data is encrypted. Once you're inside of Microsoft World, if you need encryption between two resources inside of Microsoft's world, not leaving a data center, for instance, you need to use some other technology to get that data encrypted inside of their data center. And host-based encryption is one way to do that. Okay. So here's a slide that kind of gives you a little bit of comparison between what these things can do. So storage server-side encryption. It's encryption at rest because it's on the storage itself, and it's the OS and data disks, not those temps and caches. So it doesn't get those because these are at the host. The data flow between the data flows are encrypted between storage and compute. No, not here, because there's not. The only thing encrypted is your storage, not the host. So there's no, it has to be encrypted at the source for it to travel encrypted to the storage. You can do customer controlled keys as long as you have a disk encryption set. It does not use your VM's CPU because it's being done at the storage, and it can work with custom images because it's anything that's on the storage. Encryption at the host that we just had the diagram for gets the OS and data disks, does the temp disk, the encryption disks, and because it's being encrypted at the host, anything it now tries to write out to storage is already encrypted, so it catches it in transit inside of Microsoft World. You can control keys at the storage side if you're using a disk encryption set. And again, it's at the host level, not your VM level, so you're not burning up your CPUs. The Azure disk encryption, BitLocker, think that way if you're a Windows person. I'm getting these things, again, anything at the host because the operating system is dealing with it, but it is using your own VM's CPU cycles minimally, but it's using them, and does not work for custom images for certain things. So we'll have to, this is a quick chart to kind of figure out which way you want to go with some of your encryption. What are your requirements for encryption? So there's several ways in which we can skin this cat and protect your data. Which is right for you? We can have that discussion because sometimes when you're turning on double layers of encryption, well, there's a slight performance hit to do that. If you're doing something at the host or at the infrastructure, you're going to pay for that. So, well, if you want to manage your own keys, you're going to be paying for a key vault. Now, granted, not expensive, but you're paying for the key vault, plus your time, energy, and alertness to manage keys and make sure you're changing them and rotating them as necessary. So there's pluses and minuses to each one. We can figure out what is the best for your environment. So what about monitoring this? Microsoft has general security notifications and things like that in the platform in general. If you add the Microsoft Defender for Cloud service, there's a free version of it that gives you some overall view of what your security looks like. So it's going to tell you, in general, your storage is configured at 90% good. Your traffic looks a little heavy or something like that. So it kind of gives you some general things. But in the Defender for Cloud suite, you can then pay for specific resource defenders, which now drills in and gives you specific information about what Defender can, not Defender, what's actually happening in your storage. So things like, now, if you have the Defender for storage, let's call it the add-on, you're going to pay for storage at this point. If someone's going to try to make an attack on you, this is where you're going to get now alerts. You have automated responses available to you. You have investigations available to you to tell you what is happening in that particular attack. So the Defender for storage is looking at your environment, and because it has a lot of AI-driven intelligence sitting behind it, it knows what's normal for your traffic and what's an anomaly, and can detect these anomalies and alert you that something different is happening here. And you can be building automated responses, or you can then intervene yourself to deal with it. So, Defender for storage, activity monitoring. It detects unusual and potential harmful activities involving storage accounts. So again, AI-based, it kind of learns what your normal patterns are over time. And the longer it's running, the more it knows of what your normal behavior is, so it can detect anomalies. In addition to types of activity that is known to be malicious. And these things can now be brought to your attention, and automated responses can be configured into it. Sensitive data threat detection. So you can identify and protect sensitive data within the storage account to protect suspicious activity. So now we can get a little granular as to what kind of data in the storage account am I most interested in, and want a little higher level of monitoring and threat protection available to it. Malware scanning. So the storage account for malware can be analyzed for known threats and suspicious content. So there's Defender for Cloud, a free version, and then you want to strongly recommended, you consider the Defender for Cloud storage to be taking a look at specifics of your storage. Same with VMs. There's you can get Defender that targets VMs. You can get Defender that targets other aspects of Azure, and you get more and more detailed information about, and you get the ability to automate responses and pulling things together in dashboards for reports. So you can get a good picture of what your specific resources are doing, not just the overall picture of your environment. That the overall is important, but if you have 6 or 7 storage accounts and and all you have is the overall, then it's going to say, well, there's something in storage and you really don't have it drilled down, but that's what the free would give you. The for fee would say, we're seeing storage account X having this kind of behavior. And then you can decide what you want to do with that. So this kind of monitoring is important. Our systems are starting to get big and unwieldy as far as being able to manually look at logs or anything like that. So we need some kind of tool. Defender for storage is one of those tools. It can feed into a SIM. So if you have a SIM, it can send that data there, and you can use Sentinel, or just even log analytics to get these logs in there and be building reports to find out what's going on in your environment. There's a lot of activity in the malicious world that happens before you actually get damaged. And if you can catch it while it's happening, like in the reconnaissance phases or something like that, you can protect yourself from any kind of outage where you would have to resort to your backups to recover. So, what have we talked about today? Again, this unfortunately was a little high level, especially if you're interested in how-tos, because I'm trying to get the overall picture of ways to protect your storage. All right, so what did we talk about? We talked about controlling access through allowing public or private access only, or allowed subnets and VNets. We did not talk about not necessarily any kind of network security groups or things like that, but we want to be able to, we need to protect from where our storage can be accessed. And we thought that was our private endpoints, service endpoints, things like that, and the firewalls that determine what subnets can be allowed. We talked about controlling access to the data itself through either access keys or signatures, or role-based access control. Role-based access control, say again, is probably where you want to default and use the access keys or the signatures for unique situations where you don't want to use a security principle to authenticate the connection. We talked about encrypting data, either at the server side, which you get by default, platform managed keys, everything you have in Azure is encrypted by default. But you could also do client side if you have a client that will encrypt. You could add infrastructure encryption, which uses only platform managed keys. It's a Microsoft managed feature to give you that double layer of encryption. We can encrypt at the host, which will pick up those temp and cache disks. And then because they are encrypted and the operating system is encrypted, anything moving over to the managed disk will be encrypted inside of Microsoft in transit. And of course, in the OS itself, which is your BitLocker based, which is the VM itself will manage the encryption. So these are the different options you have, and you'll have to determine which is best for you. Just be assured that everything you do is encrypted. Anything that travels outside of a data center is encrypted in transit by default. Any data that you store is encrypted by default. You just have to get some choices of how it's going to be encrypted or how much it's going to be encrypted. And of course, we talked a little bit about backup. Backing your data to an immutable storage is probably I'll say it's a requirement nowadays. With ransomware being the scariest thing out there for a business in many ways, having your backup someplace where it can't be manipulated, it's very important. So Azure backup feature. Now for backup, you could still use Veeam and other third-party tools to do your backup, but in the Microsoft native world, it would be the Azure backup. The Azure backup stores your data on vaults, being a recovery service vault or a backup vault, and you can configure those to be immutable. And then, of course, just make sure your rotations are sufficient for your data requirements. So that will protect you against loss. What I don't have here in the summary is other things that protect you against loss, or the things like soft delete, versioning, things like that within the storage account that you can go back to earlier versions of that data or recover a deleted file. So you can protect things at the file level as opposed to the whole storage account level. So we have that as well. So it's something else to consider. And of course, monitoring. I'd strongly recommend the Defender for Storage so that you can get the specifics on your storage information. So and can potentially build in responses that can respond, Sunday at 3 a.m. when you're sound asleep. It's probably, it's potentially already responding to something so that, it's going to cut off access if it sees this kind of action or something like that. Notify you and notify your support staff or your support company or whatever. So all of that stuff can get rolling right away while you're not paying attention to it. So again, strong recommendation, especially in this security conscious world where hackers are even trying to use AI to make the attacks. They're getting far more sophisticated. You need eyes on your data that can find things quicker than a human being can. So again, that's something to consider. And that now pushes back to Chris to talk about some next steps.
Thanks so much, Dave. I appreciate it. So since we've really been talking about security, of course, the whole time, our Learning Center has put together some discounted classes that are all security related and Azure related. So those will be in your packet when you get them, and you can see the discounts there if those would be of benefit to you. I did notice we don't have any questions currently, so don't need to do any of the Q&A. So I will just note for the survey which you'll be getting, there are some lists there where you can put in what you need for additional resources that might be beneficial to you. So one is kind of an Azure security review. It's kind of a whiteboard session, no charge for that. So if that would be useful to you to kind of understand, well, where do I need to go focus next, right? Where there's a lot in Azure security, or maybe you're just considering Azure and you need to kind of do a migration planning session, again, do that workshop for you as well, again, at no charge. That's on there. You may need some vulnerability or pen testing, or obviously information on classes. So that's all just listed in the as additional resources right in the evaluation that you'll see, or you can list other things that might be useful to you. So I want to say thank you to each of you for your time today. Hope it was beneficial and educational. And thanks again to Dave for the good information. And hope you have a great rest of your afternoon. Thanks, everyone.